Heat and air conditioning test 8. All right, let's zip through this thing because we got a lot of work we got to get done out there, and it's not just busy work. We got stuff we have to fix. We have more work today than we can get done. We have to get the transmission out of that Crown Victoria to see about that oil leak just as quick as we can. I'll probably let Sean.
Hey,
I'm gonna probably let you work on that by yourself.
Hey, Mr. Reed.
Yeah.
They don't have a cover on the bottom transmission that you can pop off and stick your finger up in there and see if there's oil.
It's got a cover. It is wet.
Oh, it is.
It has wet's leaking around that cover. Yeah. There you go. So it was low enough on oil today, and it's only had like 3,000. It wasn't even touching a stick. So when we did our inspection on it, that's why I set him up with another car. In a reciprocating piston compressor, the pistons are driven by, what are the pistons driven by? In a reciprocating piston compressor, what are they driven by?
I might know what that is.
Well, reciprocating means when they go back and forth. Up and down, back and forth when they go this way. Reciprocating is when they go that way. Except in a compressor, they go this way, right? It's driven by wobble plate, crankshaft, swash plate, or all of these. Actually, that is a D, all of these, right? Most York compressors use cylinders made from what? Cast iron, aluminum, A and B, or neither A and B. That is going to be aluminum. Aluminum, most of them. The older compressors that we used to use, some of the older compressors that look like a little engine, sort of. Some of them were cast iron, but most all the compressors nowadays are aluminum. The reciprocating piston compressor used on many older General Motors designs is designated by which of the following? Now, this is pretty important stuff. If you're going to talk about parts, hello.
Yeah.
All right, you pay attention. The reciprocating piston compressor used on many older General Motors vehicles is designated by what? That's A6. 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 Two technicians are discussing variable displacement piston compressors. Technician A says the wobble plate is moved to the high angle position for maximum output when the cooling load is high. Technician B says the wobble plate angle is controlled by the pressure in the crankcase. Who is right about that? Both of those guys are right. Okay? Crankcase being the crank, not the engine crankcase, but the crankcase of the compressor, right? The General Motors variable displacement compressor has how many cylinders?
6.
5 or 7, depending on the design. Yeah. Which of the following is an advantage offered by a scroll type compressor? That's what Chelsea tore one apart. You didn't see it, did you?
They were too busy.
You weren't watching the compressor she tore apart was a scroll type compressor? All right, Chelsea, describe that compressor you tore apart. Just describe it so Archie will
take it apart, you look on the inside, it just looks like a scroll. It just goes in a circle.
Yeah, you got 2 scrolls, and those 2 scrolls, they do this inside the compressor. I mean, it doesn't have pistons or anything, and that one came off of a Ford 500. As a matter of fact, it came off of Michelle Goolsby's car, and we replaced it on that. So, and it's got seals on the end of the scrolls where they run it into that chamber. Yeah. Pretty cool how they work. Okay, so number 6 that's a D. All of these. Low engagement torque, smooth engagement, and the ability to use a small clutch. All of these. See, it doesn't take a lot to pull a scroll type compressor, really, just because of the nature of the beast. Okay, a blank is used to seal the opening for the compressor drive shaft. What is that?
What was number 6?
Yeah.
Number 6? Oh, well, let's see. All of these. That's what I said. That's D. That's all of the above. Number 7, a blank is used to seal the opening for the compressor drive shaft.
Lip seal?
I'd say both.
That's actually an A and B. That's a C. 2 technicians are discussing refrigerant oils. Technician says that the mineral oil used in R12 systems is completely compatible with R134A. If you take that R134 and put it where there's nothing mineral oil, it won't even oil anything. It'll lock everything up. Technician B says a synthetic oil should be used with R134A, and that is B. Technician B, only 2 technicians are discussing. What's the TXV? Anybody know? TXV, we talked about them last week.
I don't know what that is.
Thermal expansion valve.
Oh,
There you go. So now you know what a TXV is, right? All right. Let me zoom out a little bit on my thermal expansion valve.
They could abbreviate TEV.
Yep. What?
They could abbreviate TEV.
Well, TXV, expansion, you know what I'm saying? So let me see here. Two technicians are discussing thermal expansion valves. Technician A says the TXV senses evaporator temperature to control the valve opening. Technician B says the TXV senses evaporator pressure to control the valve opening. Who is correct? That's C. Both of those guys, believe it or not, are right about that. Okay, second page of the test. Questions 10 through 20. We're trying to get this done in a reasonable amount of time. Two technicians are discussing AC systems. Technician A says that thermal expansion valve systems use a receiver dryer mounted in the suction line. Technician B says that orifice tube systems use an accumulator in the suction line. We talked about that last week. Do you remember? TXV systems use a receiver mounted in the suction line. That is wrong. That is dead wrong. Got it?
Hey, Mr.
Technician B says orifice tubes use an accumulator in the suction line. That's the one. He's the only one that's right on that one is B.
Hey, Mr. Richard.
What?
Wes said he's going to get his license back.
Oh, well, tell him that I understand that.
That made a lot of sense.
Yeah, it does. Yeah, tell him I understand that. You know, if he needs that bad. He needs that bad.
he got it straightened out.
Yeah.
Yes, sir.
I don't know. We'll see. And that was from Tennessee thing. Okay, let me see here. What we're looking at. A fitting found on an accumulator is for which of the following? What is the fitting found on the accumulator for?
Yeah, high side, sir.
Well, the accumulator is not on the high side.
Or maybe it's on the low side.
Yeah, low side. You know, the receiver dryer, which is smaller, it's on the liquid line, that's on the high side. But the accumulator is always going to be on the low side.
That's not something you can afford to mix up, huh?
Not really, but they won't plug in one way anyway. That's B, by the way. All right, low side service. A filter can be installed in the liquid line for which of the following? That's number 12. When the system is contaminated, you can actually put a filter in there. Now, they also have filters that you can put in the suction port on the compressor. I've got some in there. You can press them in there, little screens, so that anything that's trying to come out of the system and go into the compressor will get caught in that screen. And those screens cost about $5 or $6 a piece. And I can show you all those things. It's pretty cool stuff. When you've got 3 different size screens, when you've got a screen that will fit, sometimes and you're basically putting it not in the compressor, but in the low side. I mean, in the suction line port on the suction line itself, where it hooks to the compressor. And who knows that once you've bought an expensive compressor, you don't want trash and metal and stuff going in there, right? Ordinarily, if you're taking one down that's giving trouble, the smart thing you can do is pull the orifice tube out of there and see if there's any pieces of trash in it too. If there is, you can get an idea that if you got slivers of Teflon and stuff in there, the seals in the compressor are going south. And you got to put a compressor on it. This stuff is not so terribly difficult to understand, so just remember that. All right, we're going to be doing more actual shop exercises on air conditioners as the weather gets warmer. I guarantee you we'll be, and that's what we're, right now we're doing a lot of theory stuff. But when the weather's cold, it's a little harder to do air conditioner stuff when that weather's cold, because there's not a lot of it coming in here, and there's a lot we need to do. All right, let's see. Pressure cycling switch does which of the following? Senses low side pressure, senses condenser temperature, closes the thermal expansion valve, or senses high side pressure. That's A, typically. Pressure cycling switch is what makes the compressor short cycle when it's clicking off and on really fast, That pressure cycling switch is what does that. Now, on some units, like on that Oldsmobile out there, it's the pressure cycling switch on that. It's not as prone to short cycle on that type of system as it is on some of the others. So you got to understand the particular type of system you're working on and what its idiosyncrasies are. Everybody knows what an idiosyncrasy is, right?
I heard of it before.
Each one of them has got its own little peculiar traits. Basically what we're talking about there. Okay, now then, let me see. Two technicians are discussing line fittings. Technician A says that many early AC systems used flare fittings. Technician B says modern systems commonly use O-rings to seal the fittings, and they're much easier to repair than flare fittings. Who is correct about that? That's 14. That's C. The hose that connects the compressor to the evaporator is commonly called the what? The compressor to the evaporator. What's that called? You guys remember I drew it last week.
Suction line?
Suction line. Bingo. Good answer, Brandon. All right. A fixed orifice tube does what? What about it? Does it have a pressure sensing capability?
Isn't it D?
That's going to be, no, it's actually, he said D, didn't he? Yeah, D is right. D is right. It's located in the evaporator inlet line, or line of the evaporator, okay? What type of refrigerant hose is used with R134A system, excuse me? Anybody know?
I'm just going to say C.
That's a barrier hose. You got that? All right. Okay. Number 18, an air conditioning system may use an inline filter to remove moisture from the refrigerant, to separate large debris from small debris, to reduce compressor noise, or to prevent any solids from clogging the expansion valve.
Is that D?
That's D. The tiniest place that refrigerant has got to go through is either the expansion valve or the fixed orifice. That's a little bitty place, and if you got clogging going on, that's usually where it's taking place, in the expansion valve. And some expansion valves, like on the old Volkswagen Rabbits, had a screen built into them that would clog up with crap, and it wouldn't let anything go through. You could take them out and clean that crud out of that screen, put them back together, and cool real good. All right, so let's see. Let me see. What question are we on? 19. An air conditioning system may use a muffler to do what? Store excess refrigerant, protect lines from vibrations, store desiccant to trap moisture, or reduce noise. What do you use a muffler for? Come on.
Reduce noise.
Reduce noise, there you go.
Or you can just cut it off.
What would a muffler be on a refrigerant system?
Huh? What?
What would a muffler be on a refrigerant system?
It's got just a little, looks like a muffler right on the line. You've seen them. I mean, whatever you see.
Oh, yeah.
You got that little line going, all of a sudden there's a little thing on it. That's a muffler.
Just take your muffler.
Some of them got little screens in them and stuff, but what's the function of the desiccant bag inside an accumulator?
Captures and stores moisture, don't it?
Yeah, that's it.
Captures and stores moisture. That's what desiccant always does. It's not only in the accumulator, but you'll find one of those in a receiver dryer.
Is that like the same thing you find like when you get like a brand new pair of shoes and it's got that bag that says "Do not eat"?
Yes, exactly. Or in the pills or something like that. It's really crazy that they would put "do not eat" in there. I guess they figure somebody's going to tear it open, dump it in their mouth, see what it tastes like. A variable displacement compressor uses what? 4 pistons, a variable angle wobble plate, an impeller, or a swash plate. That's number 21.
A B?
I think C.
That's a boy. B. 22. Which of the following is not a major component of most compressors? That would be a clutch, fins and tubes, piston and rings, or reed valves.
I think it's B as well.
D.
That's, well, B. That's boy. You know what reed valves are, right? You know what a reed valve is? A reed valve is basically a little valve that's resting against a hole, right? Okay, and whenever air comes in or pressure comes in from this side of the hole, everybody looking at me, or is people looking somewhere else? It blows that reed valve away from that hole, and it lets pressure go this way. But if pressure tries to go back the other way, the reed valve closes the hole and won't let it go back. And so in your air conditioner compressors, you may have a half a dozen reed valves around that thing. And so whenever the pressure goes against those reed valves, they let it go one way. They're like a one-way valve, basically. But they call it a reed valve because years ago they would make something like that with a little reed. Now they're just it's a metal strip and all that. So everybody get that together. Identify the component shown. Identify the component shown. What is that? What is the component shown?
No,
Compressors, isn't it?
What is it?
I say it's a 12-volt compressor phase or whatever.
Well,
What's
what do you
it?
think?
I'm probably wrong.
That's a high voltage compressor. You notice it does not have a pulley on either end of it. You see that? It runs on a motor, a high voltage motor on the inside. Okay, next, number 24. Identify the component, this component.
That's an accumulator.
Listen to that guy. Everybody agree with that?
Yeah.
Everybody agrees with that. That is an accumulator. There you go. Okay. Now, next, question number 25. Identify this component.
Is that the receiver dryer?
Receiver dryer. It's a cross section of it, yeah. A damper drive compressor turns the compressor input shaft A only when during high moisture conditions, B when the clutch magnet is energized, C when the engine's running, or D when the engine is at auto stop. It's actually whenever the engine's running. So write T if the statement's true, and F if the statement is false. 27 and 28. The compressors on some vehicles use a clutchless design and variable displacement. True or false? That's true. Some systems have a modulator instead of a receiver dryer.
I said false.
That's true. Yeah. Okay. Now, finally, choose one alternative that best completes the statement or answers a question. A compressor clutch that cycles on and off rapidly is an indication of what?
Low refrigerant charge.
Low refrigerant charge. Let me tell you a short story, just a very brief one. One time I was working on a Ford Aerostar. And they said the compressor would cycle off and it would stay off for 5 minutes. And then it would cycle back on. 5 minutes. It would cycle off and stay off for 5 minutes and it would cycle back on. And so I drove it, and it was a hot day, and I got out there on 231, and I would notice that the compressor would cycle off for 5 minutes at a time, and it would come back on. And we did not have scan tools in those days for Fords, not for that vehicle. And so I don't remember how I landed on this, but I went in there and I back probed the engine coolant temperature sensor with a voltmeter. Now, the normal range for the engine coolant temperature sensor, when it's cold, it reads about 3 volts. When it gets warm, it reads about 0.6. That's when the thermostat opens. On the Taurus, like the one that Chelsea just did the engine in, if it gets down to 0.45, the fan kicks on. So you learn all that by measuring this. See what I'm saying? You can get to where you're familiar with it by just measuring what it does on a good one. That's why the Treasury agents study real money and not phony money, because they want to recognize the real deal. So if you guys have got good sense and you're really serious about this, every time you get a chance to plug a scan tool in and look at the common stuff like your fuel trims, your mass airflow, and what your oxygen sensors are doing, your engine coolant, you'll be looking at that stuff so you can get used to what it's supposed to look like, pulse width on the injectors and all that. Now, you can take somebody that has all the desire in the world to fix a car, and if they just plug into one with a problem, and they're seeing stuff they've never seen before in the way of numbers, they don't have a clue. You may as well hand the tool to your grandma, you know. I mean, but and with all due respect, some grandmas may be smarter than you think. But the fact is, when I started looking at graphs on the service bay diagnostic system that would, it would actually do the sort of like the this Ease Diagnostics machine out here. It would draw a line that would give you a histograph of what a system was doing, and I would look at a bunch of parameters, and it would draw these colored lines on here. And when I first started doing this, I said, I don't even know what I'm looking at. I mean, this was really something, because I figured it's fun to look at this gray screen with these colored lines, and I know which line is what, but what is it supposed to look like? And occasionally, when I was sort of bogged down on that, I'd find another car. It's easy to do when you're at the dealership because you got new cars all over the place. I'd plug all that stuff into another car and make a recording under the same conditions and compare the two recordings. And I'd say, oh, I see now. This is what it's supposed to look like, and this is taking a dive. And so I've got a problem over there, I mean, you see what I'm saying? The more you look at that scan tool screen, the better you're going to get at finding a problem on one that's got a problem. You can look at like for instance, if you know that mass airflow is supposed to read about 4 grams per second on a particular vehicle at the operating temperature, let's say at 200 degrees, and you got one that's giving you a fuel trim numbers that are way out of kilter, and you've got no vacuum leaks or any other reason for it, you look at it and you say, wait a minute, I know these are supposed to read about 4 grams per second. This one's reading 6. And I know that's not right because the engine's not running fast enough for it to be reading 6. And so you know that since the mass airflow sensor is lying to it, you know, and we had one too, this Aztec that we drove, and it would not go over 50 miles an hour.
50?
That's all you could get out of it was 50 miles an hour. And I noticed that the mass airflow sensor could not report more than about half throttle. That's all it could report. I'd seen that before. It idled perfect. It ran perfect up to about 50 miles an hour. But when you went deeper into the throttle than about half throttle, the mass airflow just didn't have the capability to display more than about half of its range. And so it would stop giving it fuel. Well, when we got out and unplugged the mass airflow sensor so that it was having to use other inputs, that thing ran like a race car. It ran right out from under you. Bingo, we got a bad mass airflow sensor. Hello? This is him.